Now it is on, right? Okay. So what I'll repeat the thing once again. So we are going to start with our capacitance and potential in this class, right? So we'll see first what are the formulas are available in this, and then we'll start doing the equations in EAP set, right? So the first one is electrostatic potential. So electrostatic potential is nothing but the work done of a charge, unit charge, bringing from infinity to the particular point is called as the electrostatic potential. So which is denoted by the letter V, okay, and V is nothing but kq by r, kq by r. So k is nothing but it is 1 by 4 pi epsilon naught, right now. So the value of k is nothing but 9 into 10 power 9. Okay, the potential due to electric dipole. What is the meaning of electric dipole? Dipole, the meaning of dipole is nothing but when I talk about in a magnet point of view, a north pole and the south pole will be there. So two different poles are there, no, like this is called as a dipole. Okay, this is called as a dipole. Then when we talk about a dipole in the electric charges, so when we talk about a positive q and a negative q, right now. So at axial point, the formula is k p by r square, okay, and equatorial point the potential will be always equals to 0, and at any general point, okay, if any general point is given, so V is nothing but k p cos theta by r square. At equatorial means what is the thing? Equatorial means theta will be equals to 90 degree, right, cos 90 0, and at axial it will be highest, which is nothing but theta will be equals to 0 degree, okay. So relation between electric field and potential. So field is nothing but it is force by the test charge, positive test charge, right now. So what is the relation between the electric field and the potential? So electric field E is equals to minus dV by dr, okay, this is the relation between the electric field and the potential. Simple, like we know the formula for this. What is the formula for E? It is nothing but kq by r square, okay. So when we talk about in terms of potential, V is equals to E by R, okay, E by R. So when we are doing this, the R and R will get cancelled off, okay, R and R will get sorry, this one, V is equals to V by R, okay. So V will be equals to E into R, so kq by R square into R and R will get cancelled, so kq by R, okay. So this is the formula for the potential, and the relation is E is equals to minus dV by dr. So when we are using this kind of formula, when the equation is given in terms of like for example 5t square plus 6t, okay, or 5r square 6r has been given. So what is the electric field they are asking? Electric field is nothing but if I differentiate this 10r plus 6, so this is my electric field and this is my potential, okay, that's my potential and this is my electric field. So when we are doing the differentiation, like V equation has been given, equation of V is given, do differentiation, you will get the equation of E, okay. So the negative sign indicates that electric field point is direction of the decreasing potential, okay, that's the meaning of the negative sign. And electric potential, okay, so when we talk about a potential V, potential energy U, so what is the formula? It is U is equals to k q1 q2 by r, okay, U is equals to k q1 q2 by r. So when we are talking about a multiple charges in the sense q1 q2 q3 charges are there, for example we will keep, okay, what is the potential? So q1 will be acting on q2 and q3, q2 will be acting on q1 and q3, and q3 also will be acting on q1 as well as q2. So potential due to 1 2 will be equals to k q1 q2 by r means r12, right. So u23 will be equals to, right now, so k q2 q3 by r23, and u31 will be equals to k q3 q1 by r31. So when I talk about u net, the potential energy, net potential energy, which is nothing but So which is nothing but K Q1 Q2 by R12 plus K Q2 Q3 by R23 plus K Q3 Q1 by R31. So this is my net potential energy by this charge. For example, if we take a triangle, so triangle 3 corners, right? So Q1, Q2, Q21, Q3. Okay. So what is the potential energy of this? They are asking. So we will use this. Suppose if they are asking a square has been given. So square in the sense 4 corners Q1, Q2, Q3 and Q4. So how we are going to analyze this? So Q1 will be acting on Q2, Q3 and Q4 right now. So U12, U13, U14. 2 will be acting on 1, 3 and 4 right now. So already we have written 1, 2 or 2, 1 both are same right now. So U23, U24, then 3 will be acting on 1, 2 and 4. So 1 and 2 already we have written 1, 2, 1, 3 and 2, 3. Remaining is U, yes it is 3, 4 right now, it is U 3, 4. So 1, 2, 1, 3, 1, 4, 2, 3, 2, 4, 3, 4 right now. So what is the remaining thing? So remaining if you see, yeah, it's nothing like everything completed 1, 2, 3, 4, 1, 2, 1, 3, 1, 4, 2, 3, 2, 4, 3, 4, that's it right now, everything completed. So which is equals to unit. But when we talk about the distance between Q2 and Q4, Q2 4 and then 1 3. So if I talk about side of a square is A, then what will be the distance between them? What will be the distance between them? So use Pythagoras theorem. So this is A, this is A. What about this one? So R square will be equals to A square plus A square, which is nothing but R will be equals to under root of 2A square. So it is root 2A or A root 2, A root 2. So this is A root 2, the value of the diagonal, any diagonal, A root 2. Okay. So we are going to write U net. U net will be equals to K Q1 Q2 by, or else when we talk about every charge Q1 equals to Q2 is equals to Q3 is equals to Q4 is equals to Q. Let's keep this one. So what will be, what happens, K Q square I can take commonly outside 1 by A right now. So that's the formula, right? If you see here 1 by 4 pi epsilon naught Q1 Q2 by R right now. So 1 by A plus 1 by A plus 1 by A plus 1 by A, 1 2 3 4 5 6, so 6 times right now. So but 4 times only I can write it. For other two things I should write like 1 by root 2A plus 1 by root 2A. So I can take A also commonly outside, which is nothing but KQ square by A, 1 plus 1 plus 1 plus 1 plus, and this is 2 by root 2, right? 1 by root 2 plus 1 by root 2, it's 2 by root 2. So what is the thing I can analyze here? KQ square by A, KQ square by A into 4 plus 2 by root 2 into root 2 by root 2. So will get cancelled off. So KQ square by A into 4 plus root 2 is my answer for this kind of questions if they are asking. Okay. So this is my potential energy. That's my potential energy. Got it? Done? Yes, we'll go ahead. So capacitance, the next thing is capacitance. So capacitance is the ability of a system to store energy, okay, and the symbol will be looking like this. So when we talk about any kind of a battery, like we can say capacitance is a kind of battery, is a kind of battery, right. So the general formula is, it is C is equals to Q by V, the charge by the potential, okay. And when we talk about a parallel plate capacitor, like capacitor also can be connected in a series type, right, and then capacitor can be connected in parallel type, right now. So that's the thing we are going to see here. So parallel plate capacitor, so in vacuum C is nothing but epsilon naught A by D. What is A? The area of the capacitor, and D is nothing but the distance between the two plates. So with the dielectric constant, so in place of C is equals to epsilon naught A by D, we will write C dash will be equals to K times epsilon naught A by D. So I can say this, C dash will be equals to K times C, like K times, like it will be increased. Dielectric constant, if we add, the capacitance will be increased, okay. And energy stored in the capacitance, which is nothing but U is equals to half CV square, or else we can rewrite this as C, no, like I can substitute here 1 by 2 CV square. So 1 by 2 C is nothing but Q by V into V square, right. So I can say this as 1 by 2 QV by only of Q into V, that's it, no, of Q into V. Or else I can say this as, this one I can rewrite this as V is equals to Q by C, V is equals to Q by C. So this one 1 by 2 into C into Q by C the whole square. So 1 by 2 C into Q square by C square, 1C and 1C will get cancelled, 1 by 2 into Q square by C, 1 by 2 into Q square by T, like Q square by 2C of QV and 1 by 2 CV square. When capacitance and potential is given, I can use this formula of CV square. When charge and capacitance is given, Q square by 2C, and when capacitance and charge and the potential is given, 1 by 2 Q into V, okay. So only one formula you need to remember of CV square, remaining I can derive from this C is equals to QV. So energy density, like stored per unit volume, like energy density is nothing but energy stored per unit volume. So U is equals to of epsilon naught E square, that's the formula for this, okay. You can take this formula and we can go for the next one. Done? Okay. So combination of the capacitance, like we have talked about the parallel and series and the parallel combination, right? So for series combination, it is opposite of the resistant type. So resistance, what we will do? So Rs will be equals to R1 plus R2 plus R3 and it goes on. For 1 by R parallel, it is 1 by R1 plus 1 by R2 plus 1 by R3 and it goes on. So but in terms of capacitor, it is totally opposite. So we will use the resistance formula for capacitance series, like resistance series formula for capacitance parallel, right. So 1 by C, S will be equals to 1 by C1 plus 1 by C2 plus 1 by C3 up to 1 by Cn, like how many capacitance we are adding. If we are talking about 3 parallel capacitance, so C parallel will be equals to C1 plus C2 plus C3, right. So this is the thing. And when we talk about capacitance, capacitance in series, no, like the charge will be same, and when we talk about parallel, potential will be same, like question can be asked, what are the things will be not changed when the capacitors in series and the parallel combination. So for series combination, it is charge will be same charges for all capacitance, and for parallel same potential for all capacitors, okay. Next, if we talk about the dielectric and a common potential, so capacitor with conducting slab, so formula is C is equals to epsilon naught A by D minus T. And when we talk about a capacitor with dielectric slab, conducting slab and dielectric slab, and the T is nothing but the thickness, okay. So C is equals to epsilon naught A by D minus T into 1 minus K, and it is epsilon naught A by D minus T. So when common potential after connecting two capacitors, okay, so this is the formula, V is equals to C1 V1 plus C2 V2 by C1 plus C2. And when we talk about loss of energy during sharing of capacitors, sharing of charges, so U will be equals to C1 C2 times of V1 minus V2 the whole square by 2 times of C1 C2, okay. You can take this formula and we can go for the next one. Okay. So common potential and energy loss, that's the thing we have talked right now in the last slide. So yeah, we'll go for the question now. So 64 identical water drops, each charged to a potential of 10 volt. So coalesces to form a single large drop. What is the thing they have given? 64 identical water drops, okay. So 64 identical water drops coalesces to form a single water drop. Right now So the potential of the charge drop will be, what is the potential? Like they have given the each charge to a potential of 10 volt, each thing 10 volt. What is the bigger one potential? So we have time start now, time starts now, like if you have a solid 1 minute now, you can give the answers now first. Yes, this type of question we have done in the units and dimensions also. Yes, the same kind of question, like a different problem, a same concept. Yes. So we'll do, so V big will be equals to n power 2 by 3 times of V small, right? No, that's the thing. So when we talk about n, what is the n here? 64. So 64 power 2 by 3 times 10, the potential is 10, okay? And what is this 64? How we can write the 64? So 64 we can write in terms of 2 power, I mean let me take 2 into 2 2s are 4 and 4 2s are 8 and 8 2s are 16 and 16 2s are 32, 32 2s are 64. So I can't use this. So how many times? 1, 2, 3, 4, 5. Okay. Can we take 4 cube right now? So 4 into 4 it is 16. 16 into 4 64 right now. So 4 cube power 2 by 3 times 10, this 3 and 3 will get cancelled. 16 into 10, which is nothing but 160. So option B is the correct answer for this question. Option B is the correct answer for this question, right? So the next question, 5 identical metal plates are placed parallel to each other. So identical metal plates are placed parallel to each other. The distance between the consecutive plates is d. If alternative plates are connected to each other, the equivalent capacitance is, okay. So start the question now first. So simple now, like what is the formula for the capacitance? Usually C is equals to epsilon naught A by D. When we are talking about the consecutive plates are connected alternatively, we have seen the formula, it is nothing but n minus 1 into epsilon naught A by D. So we have what they are telling here, so 5 consecutive plates. So n is nothing but n is equals to 5. So 5 minus 1 into epsilon naught A by D, which is 4 epsilon naught A by D. So which is the option? Option C is the correct answer for this question, right? So the next question, a 20 microfarad capacitor is charged to 500 volt, okay? So C is equals to 20 microfarad and it is charged to 500 volt in a parallel with an uncharged capacitor, okay? Uncharged capacitor of 10 microfarad. So let me underline the given here. 20 microfarad capacitor is charged to 500 volt and then connected to a parallel with an uncharged capacitor. So the common potential is, so your time starts now. Last 30 seconds. Last 30 seconds. Yes. So whoever watching can give answer in the comment section. Okay. So see, the common potential will be equals to C1 V1 plus C2 V2 by C1 plus C2. Right. So here C1 is given as 20 microfarad. It is nothing but 10 into 10 power 20 into 10 power minus 6. C2 is nothing but 10 into 10 power minus 6. Right. And V1 is equals to 500. What about V2? It is 0. Now you can calculate it here. So 20 into 10 power minus 6 into 500, and this is 0 now, I can neglect this out. So C2 is there but V2 is 0. So 0 into something is 0, divide by 20 into 10 power minus 6 plus 10 into 10 power minus 6. So now give the answer first. Yes, only simple calculation, no? Yeah. So 1, 2, 3, 3 zeros, so 2 into 10 power, or I can take it, I can take this 10 power minus 6 out. So 20 into 500 into 10 power minus 6 divide by 20, and 10 power minus 6 I can take it out now, 10 power minus 6 into 20 plus 10. So 10 power minus 6, 10 power minus 6 cancelled out. So remaining 20 into 500 divide by 30, 0 and 0 will get cancelled off. So 20 into 50. So 2 into 5 is 10 and remaining 2 zeros divide by 3. So and this is 3 times and 1 time again. So what is the answer? 333.33. It goes on, right now. So 3.333. So 2 zeros are remaining here. So 2 and 3. So 333.3 is the answer for this question. Got it? So the next question. A parallel plate capacitor is charged and the charging battery is then disconnected. If a dielectric slab is now introduced between the plates, which of the following remains constant? So the potential difference, capacitance, energy stored, or the charge. So what is the answer for this question? Yes. So the charge will be the answer. That's the correct answer. Okay. So next question. The work done in moving a charge of 5 coulomb across a potential difference of 10 volt. So work done formula. What is work done formula? Q into delta V, right? So what is Q? 5 and delta V is 10. So which is nothing but 50. Answer 50 joules. Option C is the answer for this question. So next question. The electric potential V at any point x, y, z is given by V is equal to 4x square and the electric field at a point 1 meter, 0 and 2 meter. Okay, this is the question. So when we talk about this, V is equal to 4x square. When we are talking about the electric field, E is equal to minus dV by dx or dr. Right now dx is the thing. So minus dV by dx times of 4x square, so which is nothing but minus 8x, so 8x in the sense I cap, no, it is 8 I cap and x is given 1, so minus 8 I cap is the answer for this question. So option B is the correct answer, right? So next question, 3 capacitors of 2 microfarad, 3 microfarad, 6 microfarad are connected in series. They have connected. So what is the equivalent? Equivalent in the sense 1 by C will be equals to 1 by C1 2 plus 1 by C2 3 plus 1 by C3, that is 6. So which is nothing but I can take the LCM as 6 right here. So 3 times plus 2 times plus 1 time divided by 6 will be nothing but 3, 5 and this is 6 by 6. So 1 by CS will be equals to 6 by 6. So C parallel, like total net will be equals to 1 microfarad. That's the answer. Option B is the answer for this question. Right? I hope you have got some idea about how the questions will be on this capacitance and the potential chapter. So once again you can go through this video, right. So see the formulas and see the questions how they have asked. Okay. So with this I will end up this session of today's class. So thank you guys, we will meet in the next class.